Right, so from our previous exploratory into GitHub Actions and packages, we now have a repository that is building our software and generating a container. And now we're going to focus on the security aspects and what we can add from the GitHub side of things to increase the security and quality of our source code. If we click on the settings tab of our repository and into the security and analysis, we can see that GitHub provides us with a number of features to increase the security aspects of our software. This being predominantly the dependency graph to give us insights into the dependencies that we're using within our projects. The Dependa alerts, so we can receive any alerts on vulnerabilities that may affect those detected artifacts. So let's turn that on, as well as here Dependa security updates. So this gives us the ability to upgrade to non-vulnerable dependencies, i.e. Dependa will open up a pull request for us specifically in our repository if and when a vulnerable dependency is detected for us. So this can be very useful to take away some of the drudgery of the upgrades and get some sort of feedback as to whether or not the new patched versions of those vulnerabilities can be used in your software. So, you could get the automation of your tests to execute against that new version of the updated package and verify this for you in an automated way. Then we've also got the GitHub Advanced Security, where we can opt into code scanning and secret scanning, as well as controlling certain aspects as to teams within our repository that gain access to this information. So with the Dependa security turned on our repository, we should start to see some activity being performed, and there we have it. We've now got Dependa telling us that we actually have a security vulnerability in our dependencies of our projects. So by clicking on this button with the See Dependa alerts, it takes us to the security tab. Equally, you can just navigate to the security tab and on your repository when it's enabled, the Dependa alerts, and then we can see here that JUnit within our pom.xml is actually vulnerable to a security alert. So if we click on this JUnit, dependency here, we can see that at the top already Dependa has opened up this pull request for us. It's been flagged with a dependencies label, which is nice and convenient from a discoverability point of view for pull requests that may be related to development work and that of Dependa. And then it gives us some details on the actual vulnerability and remediation. So we can see that this is found inside our pom.xml with a nice clickable link, which will take us to our pom.xml that we can scroll through and look through our dependencies if we see fit. It gives us some information on the remediation, as in the version number that we need to potentially move up to that's going to help fix this. And that's what the pull request has actually already implicitly done for us. So it's created that change necessary for that to be done. And then we've got the details of the actual vulnerabilities. So we can see that this particular vulnerability has come from the GitHub advisory database. So this is an advisory database that culminates together a number of vulnerabilities, not just on GitHub, but from other sources, and provides this information as a feed within GitHub to do the analysis and detection of vulnerabilities on your software. We can see that this is associated with a particular CWE and some other details, as well as the security researcher that was, or the person in the community that was responsible for reporting this vulnerability, as well as then the details and references and anything else that might be applicable to that vulnerability. We also re-rendered that here, so you don't necessarily have to click on that, but of course it's only a summary amount of that information that's available to you, and GitHub is all about providing this information to make it easy for you to make an educated decision about what you want to do with this. Now, equally, we can resolve this and decide that we're not going to fix this, and we can record any type of these 5 types of remediations, and these form part of our audit trail. So not only is my handle associated with the remediation that I'm choosing here, but it effectively forms part of an audit trail that can be reviewed by your InfoSec team, or you can go back and try to gain a better understanding of why you might have maybe ignored that particular fix if you're doing that, and as to what the reason might actually be in that case. If we go and take a look at the pull request that's also been created for us here, on the Dependa side, we get another link to this banner as to the specific security vulnerability that the pull request is fixing. And we can see that Dependa has created this branch for us, which is Dependa Maven JUnit 413.1. So the branches that Dependa actually creates for you utilizes the package management system and the artifact inversion to try and generate these things for you to make the branches very easy to understand as to what they're presenting without having to go through the change set. Within Dependa and the pull request itself, it gives us a summary of what it is that it's actually physically updating. And then some nice links around connections to the release notes for that particular release that we're updating to, maybe some links to a change log, as well as any commits that are associated within the change set for this particular version release. So we're going from 4.13 to 4.13.1, and we can see that there's actually more changes in here that aren't just specific to the security advisory, which we can see here. There's some other changes in here as well. So this is very nice to be able to get all this information in front of you as a developer without having to actually go hunt it all out. The other thing that Dependa is producing for us here is a compatibility rating, and this is based on the successful statuses of workflow jobs and executions and commit statuses that are associated with this Dependa changes being raised in the open source community. So on repositories and other repositories that have had a similar pull requests opened by Dependa, 97% of those have been successful CI builds. So this gives us a relatively high confidence rating that we're probably not going to break ourselves based on the feedback of what has been observed around this pull request on other repositories. And Dependa also has a very rich interaction model that you can interact with using the chat commands, and this is always provided to you, so you can reference these as you see fit. The other thing that we have here, because we added the GitHub Actions workflow, we can see all the actions execution associated information from our workflow. We can see that we even published a container image associated with this. So it is the container that was generated specifically for this particular build, but we can also see here that we ran on Ubuntu and Windows and our tests and everything passed there. So we have confidence here that we could actually just go through and merge this pull request immediately. So we can choose our merging type that we want to operate on and merge this straight through and get rid of this security vulnerability. If we did merge this into our main branch, the security vulnerability would be automatically closed out for us. So let's go about doing that and merge that through. And by virtue of merging that, we should see in the security tabs that our Dependa alerts are now showing no Dependa alerts on this repository now. So that's the Dependa aspects. The next side of the fence that we want to dip into here is the code scanning. And the code scanning has to be enabled within the repository to turn this on. This will consume a license of GitHub Advanced Security, or potentially one or more licenses, because it's based on a committer model on the repository. So I'm going to opt in on this repository and enable GitHub Advanced Security. Implicitly on our organization, we have secret scanning enabled. And so this is now going to go through and scan our source code and our commit history, looking for any secrets that may be present within our repository. Now, the secret scanning and the secrets that it's looking to detect are tokens and secrets that are associated with companies that have worked with GitHub to provide patterns for their secret tokens. So this could be Azure, it could be AWS, it could be Google Cloud Platform, Pulumi, HashiCorp. And so the list goes on. I think we're roughly about 37 today, and it's continuing to expand. There's also a new feature coming up where you'll be able to define your own custom patterns, but this is currently a Starship feature, which is not available to the community yet, but it is coming very soon, where you'll be able to define your own custom patterns for maybe you have a very specific token type for your own custom software that you want to define, and you'll be able to actually do that. So we'll leave secret scanning to go and to execute in the background. It may take a little while for that to go and scan through our repository, but any detections that it makes, it will show up under our security tab, which we'll check on in a moment. Now, the other aspect that we want to talk about here is the CoQL security scanning that we can add to our code base. And this comes from the acquisition of Semel and their CoQL engine, and that is now built into the GitHub ecosystem. So we can simply click on Setup, and we can see that CoQL analysis is right at the top of our Actions workflow. So this is going to provide us an ability to do this within the Actions ecosystem. Now, this is GitHub's own ecosystem for doing static code analysis. And we're going to set this up in just a moment, but we've also got support for a bunch of security analyses from the marketplace. So here we've got the Anchor container scanner. So Anchor have created a workflow that is, if we adopt that, we'd be able to scan our container. We've got other vendors in here like Codacity and Thunderscan, and the list goes on. Some of these may actually, so like Snyk, require a license for those particular services for you to actually use them. The same with Veracode, you would need a license for that side of the feature set, but ultimately we can integrate this with our GitHub Actions ecosystem and have the scanning being form part of our continuous delivery mechanism. And for now, we're going to focus in on the CoQL analysis, and I'm just going to click set up this workflow. So like we saw before with the previous templates, we get given an Actions workflow that's already pre-populated for us, and before we commit it to the repository, we've got some ability to make some modifications to it and see that this is right for us. So in this particular instance, we're going to have a workflow called CoQL. It's going to be only interested in pushes to the main branch or any pull requests which are targeting the main branch. But outside of that, we're also going to schedule this to execute periodically using a cron statement. And so this workflow seems all right to me, so let's just move on. As part of the phase here, as part of the workflow, we're going to perform some analysis on our code base. So to perform this analysis, we're going to have a job called analyze. We've given it a human readable name. It's going to execute on Ubuntu latest. It's got some details around the permissions on the GitHub token that we require as part of this. So as I alluded to in the previous session, you can tweak the permissions on the default secrets.github token. And this is one example of showing how you can do that. This is also going to use a strategy here, and by default it's using Java and JavaScript, but we don't have any JavaScript in our repository, so we're going to limit this to just the Java language. But because this is defined as a matrix, it's as simple as me just adding another language here if I wanted to expand this in the future. Then looking at the actual workflow that's going to execute for us, we perform a checkout. And then CoQL will do an initialization phase, which will analyze and set itself up for the analysis, of your particular language or languages. So in our case, this will be specifically Java, but it will download the predefined query packs, which are ready to analyze your code. This is going to call auto build, and auto build will take a rough guess at how your software builds, but if you have any custom build parameters or special things that you need to inject into your build lifecycle, you probably really shouldn't use auto build, and instead, as the documentation says here, you fall back to using a run. Auto build here is really present just so we can bootstrap the majority of simple projects. So your mileage will vary with the usage of auto build. Equally, we could just uncomment this and have a run Maven build. In our case, auto build and Maven are compatible, and we don't need to pass any special command line parameters, so that will work for us. So we'll leave that in place. And then we have the final step, which is the performing of the analysis after the database and has been built for us by the actual build phase. So what we're doing here with a compiled language is that the initialization will set up the traps necessary to capture the information when you compile your code. We then compile the code, and then we build the database and analyze it off the information that we collected as part of that execution. So we'll just commit this file in because this will work on our simple project. And if we look at the actions now, we can see that there is a CodeQL execution that has been kicked off. But this is a matrix build using only a single language, so there's only one thing within our matrix. And if we click on this, we can then watch the job execute and detect the necessary security vulnerabilities that might be present in our code. So it's now initialized and got our query pack down, and now it is running our build. So this is our Maven build from before. Now, of course, this is slow again because we're not leveraging our caching. So if we were to actually apply this with the end result that we got from the previous session, we would, of course, need to utilize the artifact cache as steps within our build here as well. And that would significantly speed up our code scanning time. What we're doing here is just using this out of the box just to show you how simple it is to actually integrate and get started with it. But of course, you will need to tweak it to get the most out of it in with respect to speed and execution. And of course, there will be some variable aspects to this based on your needs within your build system itself. So we're just about finished. So here we are creating the database, and it's going to run 31 queries on our code base right now. So these are pre-compiled for us and provided by the community. These are the defaults, which are our high quality queries, but you can modify the CodeQL scanning to include more quality-based aspects, or you can even potentially modify it and pull in other queries that are being provided by the security community or maybe other vendors. So that has published those. And if we now click on our security tab and go to our code scanning alerts, we can see that a scan was in fact completed using CodeQL 11 seconds ago, and there were 0 alerts inside our repository. So we're pretty good to go at this point. There's also this nice link up here to add those other types of workflows. So we've already got that CodeQL workflow, but you can add the Anchor code scanning and Trivy code scanning and container scanning, or any other security tool that works here. The other aspects around this is that these code scanning alerts, when present on your repository, will take uploads of any Serif JSON. So if you have opted into the GitHub Advanced Security license and are using it on your repository, any tools that generate Serif outputs can be used to generate tool reports within your repository. So ESLint, for instance, has a Serif output that can actually be published within here. Speaking to previously the other aspect that we enabled, which was the secret scanning, we can actually see that we do have a Google API key that has been detected inside our code base. So this is the secret scanning that happens in the background, and we enabled this while we were waiting for our CodeQL results. This has been detected in our code base. You can click on the actual detection. It will take you to the file, and we can actually physically see that it's this particular value that exists inside our code base, which is an API token, which almost immediately gives it away that this is probably something that shouldn't be committed in our code base. But it's been detected and matched against the Google API key within the code base. Then now we can do something about it and either revoke it, go away and pull that and ensure that it's not used, and protect ourselves from this being exposed. Now, because this is an internal repository, this actually hasn't gone through any revocation, but if you're a public repository and you do this and you publish a token, for instance, an AWS token, it would be presented to AWS and they may revoke it immediately for you to prevent that from being a problem. So it could invalidate your token, and then it's up to the vendor to actually decide on the remediation or how that will do. GitHub doesn't have any part in that. It just identifies that this, as opting into secret scanning, it will inform the vendor that this was something detected in your code base, and it's up to the vendor to then confirm that that is a valid token, and then what remediation steps would actually be performed by that integration with GitHub. At no point does GitHub sort of store this information outside of that that loop. Of course, it is committed inside your code. Now, if we take this to its ultimate conclusion with our more all-encompassing repository with all our workflows in place that we showed at the end of the last workflow system, we can see that we've got code scanning integrated on this as well, which is using a similar type of approach, but it's been cleaned up a little bit to leverage the GitHub Actions cache as we had before. So this significantly increases the speed of our execution, as well as adding that custom build step. So no longer using auto build and instead just calling Maven compile in batch mode specifically from the command line. The other thing that we have added here is that we've also added the container image scanning. So we've utilized this community provided scanners, and here we're actually calling the Anchor and Trivy code scanner on our container to generate two sets of scanning, because why not? It's free to use and integrate, so we want to do a comparison against both of these tools and ensure that we get absolutely everything. Our workflow specifically for this particular process is a little bit more complex and different. So here we're looking to specifically trigger on any registry package that is published or any workflow run. So if we publish to the GitHub package registry, it would generate an event that would trigger this. But we're also, in this particular instance, triggering on the end of an execution of a workflow. In this case, the build test publish workflow. If it's completed, then we're going to trigger this container scanning off the back of that. The other thing that we are doing here is protecting ourselves from a Dependa pull request. And the reason that we're doing that is that we need access to secrets to be able to pull the image back down, and Dependa does not have access to those secrets. So there's no point executing this if it was a Dependa triggered build. From here, we are extracting the container, and this is, of course, using the container status that we alluded to before, where we get the status and we're looking specifically for that container image published, and ours was -app, and as such, that will generate the container that we're interested in scanning. We then export that as a array of containers, and then in our next build step, we have the Anchor container scanner. So this job is going to use a matrix of that array. So it's going to take those array of containers. In this case, there's only one container, so it's an array of one. And that's then going to log into the GitHub container registry and then use the Anchor scan engine to specifically scan that container. When it's finished, it's catching the results as a Sarah file to the output for our workflow, but then it's also using this CodeQL action that GitHub provides to upload the Sarah report that it has generated, so it will appear in our security tab. And it's a similar type of thing for Trivy, where we are once again taking the array of containers that were detected. In this case, there's only one. Once again, signs into the Docker registry, This time round, it has to pull the container first. So we explicitly pull the container, and then after that, we then have a different action to invoke that will generate the serif file for Trivy, and then we upload those Trivy results. So in this case, we can see that the code scanning alerts is a little bit more busy. We've got the ability to filter by tool. We can see that we've got no code vulnerabilities from CodeQL, but both Trivy and Anchor have detected differing degrees of security vulnerabilities. And those security vulnerabilities are typically in relation to the software packages inside our container. So taking an example of the libc detection here, we can see that there's a vulnerability associated with it like we had before. We've got links to a CVE that we can go and click into and understand potentially what versions we can update to, and we can currently see that this is actually not fixed. So this is a vulnerability we can do very little about. We can potentially identify this as false positive, won't fix, or we can leave it open and await a version to actually come to fix this, and we just keep this here as a record of facts within our containers. So your mileage will vary depending on what you can actually physically do with this, but this information can be extremely useful depending on what you want to do with it. The containers, to fix some of this, we could actually update our container to the latest security packages when building it. We're currently not doing that. And that might actually fix things. If we take a look at a Trivy result before it was Anchor, we can see that the outputs vary a little bit. This is up to the individual tools, and this is actually a link to their vulnerability database rather than the more generic vulnerability database that we ended up to with the Anchor result. So that's our high-level overview of the security aspects that GitHub can provide and put in front of your developers to move your security posture towards the development lifecycle. Thank you.
So that was a bit of a whirlwind tour across some of the security features there.
I love it. I absolutely love it. I think CodeQL and Dependa are such awesome tools for ensuring the code quality of what's being developed, and that just gives organizations so much more confidence that when they go towards automated CI/CD deployments, that they can trust the code's going to be secure when it's pushed forward and that the quality is there. I think that's awesome. I happen to use Dependa a lot for my own repos. Because there's lots of them I've got where it's just keeping them updated it does it for me. It's brilliant. Yeah, I love it.
Yeah, especially if you can tie that stuff into the automation and get confirmation that you haven't broken anything. It's extremely valuable. One of the questions that sort of came up during that session was sort of getting some clarity on the aspects of the security products and what's available to you today. All the features that we showcased today are actually available on a public repo. So if you are practicing open source, we give you these tools without cost to apply to your repositories and actually leverage them to ensure a higher quality of the open source community's software that they're building. When it comes to using private or internal visible repos, that's when we start to fall behind the licensing aspects of this, and GitHub Advanced Security inside an enterprise or organization will require you to have a license to leverage some of those features outside of the Dependa vulnerability detection that we showcased today. On the topic of secret scanning, we also have a little bit of a duality here in that public repositories, if you commit a token, we will inform the vendor that has matched that token, and they will do some verification as to whether or not they want to pull it. So in the case of your cloud-based credentials, it could be very likely that those credentials are invalidated before you even know about it. And that's a protection mechanism that we work with the providers to scope that type of activity. on private repositories. So if you're paying for a license of GitHub Advanced Security to perform the secret scanning, that's effectively behind your own barriers. So it's not exposed to people outside of your organization. And as such, it's up to you to decide what activities you want to do. If you want to revoke it, if you want to just mark it as a false positive, or if you want to potentially rewrite your Git commit history to expunge all references to it. Now, we don't provide any tools specifically for that because, of course, rewriting Git history is a kind of tactical nuclear approach to expunging this from your repository, and as such, you're modifying the history and therefore invalidating everybody's clones from that might have a copy of that repository. One of the other interesting sort of questions that came up along the way was around CodeQL. Sam, have you got something to share on that?
Not on CodeQL, on Codespaces.
Codespaces.
Yeah. So we were just going to show quickly, we've got a couple of people asking about GitHub Codespaces. Now, I absolutely love Codespaces. I think Codespaces are amazing. It's a way of building your environment, your development environment, leveraging Visual Studio Code, but in the browser, to be able to have a consistent environment between people. And it's really simple to get started with. So the bookstore TechDays repository has got a code space set up in it. And to open it up, all we do is we go to the code button here, and we go down to open with Codespaces. Now, I started this moment a few minutes ago just to make sure it was cached. These can take anywhere from like 30 seconds to a few minutes to build up, to start up. And behind the scenes, it's running a container that's got a remote container with all of the dev environment, and then presents the Visual Studio interface via your web browser. So by opening that up, we can see that we've got all of the tools installed. We've got Java, Maven, and other kind of tooling installed ready in this system. And it's also hooked up with our repo, so that if I go to the source control, I can see the changes, and I could make changes and push them straight through, but also the command line setup. So if I do a git status or a git remote show origin, we can show that we've got all of that set up and tracking. So all the authentication mechanism is ready to rock straight away, and you can get straight into coding very quickly without having to create another dev environment on your local machine. Now, one of the other cool things about Visual Studio Codespace is that you can also hook this up with Visual Studio Code. So although the web interface here is being presented through my browser, if I've got Visual Studio Code open, I can see from the Remote Explorer plugin locally that's running that I've got my demo TechDays book open, and I can open that and connect to that from Visual Studio Code locally. And all that's doing is it's still running that back end inside GitHub, container inside GitHub, but it's now giving me the user interface directly inside Visual Studio. So when I command tab between my screens, which is on the wrong screen, I actually get to tab between different between Edge and Visual Studio Code. Is there something you wanted to just add in there, Peter?
Yeah, the other thing to point out is that each branch within your repository can have a different code space and the code space configuration, because the definition of your code space environment is actually contained inside the branch. So this adds the ability to have infinite options of explorability and modifications, and you know that unless you commit it, you haven't broken anybody else, for instance, on that particular branch. But it allows you to potentially trigger, try out, and spike and do new things that you might not want to do on your local development machine, because if you brick that, it's a bit of a painful exercise resetting your tools.
I think that's brilliant. I didn't know that, but that is awesome. So that's in the same kind of way that the workflows are kept in track with the repository. Your dev environment's kept in track with your repository. That's awesome. Just to highlight what Peter's going on about there, the .dev container folder contains these files here. The dev container JSON file is the one that kind of like glues all these different pieces together. And the dev container JSON file, in this instance, is using a Docker Compose file to define what that remote container does and looks like. It's setting up some forwarded ports. So if I was to run a Maven build, I could actually run that test, and it would magically port forward through from the browser to the remote machine on those forwarded ports. It's installing a load of extensions, so we get consistency when we spin this up on for different people. They have the same extensions installed, and there are some other settings that are being set as well. Now, that Docker Compose file is a relatively generic file, and we could use in the dev container JSON, instead of a Docker Compose, point to a Docker file itself rather than just a Docker Compose file. But I think that as Peter alluded to there, being able to track these as part of your repo and keep them in the same kind of development sync. So you have to do a pull request. If you make a change to the dev container, that has to be approved and looked at and reviewed. I think that's a really powerful way of maintaining development environments.
Yeah, the other reason that we're using Docker Compose here in this context with a single container is to actually allow us to access the Docker environment, so we can spin peer containers. So the purpose of this particular repo configuration means that I can actually start other Docker containers from my code space and have them as peers of my actual code space container. That's the only reason that we're using Docker Compose. The other aspect that you can do is just reference an image directly, and code spaces will use that, so you don't even have to build the Docker file. In this particular instance, the container that's in use is one that's actually pre-built for our tooling and includes some extra tooling like the Azure CLI, as well as Terraform and various other tools that I would previously have to have installed.
That's awesome. We'll drop into the chat some links to where you can look at the Docker files and some links to how the devcontainer.json file is set up. But I think at this point we're a little bit over time, so let's move on to the next session,